Here we have a deep tissue massager. I've actually done one of these, but it was under a different kind of box and name, but I bet it's out of the same factory. I don't know what happened to that one. I think I gave it away to someone. Now, with this one here, to me, it looks brand new. Annoyingly, they didn't give me any power adapter with it, but it says in the instructions here that it needs a 12 volt 2 amp. And what they have given me in the box is a cigarette lighter charger, so you can see 12 volts here. Now I've got this little gadget down here, and if I plug this into here, it's not coming on. So when I press on here, it's not doing anything. It's not vibrating, nothing's lighting up, so nothing happens when I press these buttons here. Yet this is definitely working, because if I unplug it from here, you can see with my multimeter that I do have 12.4 volts. Yeah, it's just gone off now because that went off there. But yeah, 12.4 volts, and it's not doing anything. So let's take it apart and see if we can find out what's happening. First things first, I'm just going to make sure that the fuse hasn't gone in this part here, because these do have a little built-in fuse. Let's bring it over to the mat and see if we can get this deep tissue massager working. Okay, still for sale on Amazon here, £30.52p, next day delivery, normally £32.45, and this with Amazon Prime. Look at this, 1,000 of them sold in the last month. It's crazy. It's an amazing amount of things that get sold on Amazon that you just think nobody would really buy. So first things first, let's see what's happening here, because we can go from, actually, we'll know if it's the fuse, because I can go from here to here, can't I? I don't even have to take this off. If I go, this should be the outer one, so this should be here, which it is, and the middle one is going to be in here, which it is. So it's not, we don't even have to take that off there, but if you have a little sneaky look in here, you will see that there's a little fuse to protect it. So we don't need to check that now. Now, when I did these before, I think it was some kind of MOSFET thing. H-bridge is coming to mind, because it needs to work in both directions. You know, it will spin this way, and then the balls will spin this way. And I think there was some H-bridge. There was two MOSFETs type thing making up some H-bridge. Don't know why I remember that. So, we should be able to, you can see this has had no use. We should be able to get into this. There's the zipper, there we go, big zip here. There we go. Ta-da! I think this is the same as the one I had before. It looks very similar. I'm now wondering if the chips have gone again. Mind you, I think on my one, I think the light, I think it lit up, but it didn't do anything. This one here is completely dead. So that comes along here. This lead here comes along and it goes into here. So I think first things first, we'll see if we have continuity between here and the ends. Right, so we have power going in here. Well, it's definitely connected. It's got a blob of glue on it as well. I think that's going to be all right. Let's turn it upside down. Ah, these are the two H-bridge things. Mind you, we have three. A motor here. It actually smells. Uh-oh. It smells of burning. I can smell burning coming from somewhere. Oh, no wonder I can smell burning. Right, what we got there? A melted, what looks like a transistor maybe. Is it labelled up the same as that one? J3Y, no. AOA, is it? Well, I think that's our problem. So we've got power coming in. Where's power coming in? Power coming in here. Power goes up around here, feeding this chip. Goes round to feed this chip. And feeds that. That's going to be a voltage regulator there, I think. Maybe turning 12 volts into 5 volts, possibly. And then that goes off to there and comes around here. Where's, that's the negative there. Oh, that's the negative there. Right, okay. So it feeds that pin. So where is this resistor being fed from? Is this the ground up here? This is going to be ground, I presume. Middle one goes to one of these wires here. Heat. It's labelled up as heat. Okay, I'm going to Google that and see if it brings anything up. It's amazing the smell that's generated from that there. I can smell it from here, about a foot away from it, I can smell it. Anyway, I can't really get the markings off it. I've typed in what have I typed in? AOA, but there is definitely something in the middle there. Yes, there's a crack through the actual thing. It could be an L. If I type in AOLA transistor, then it is coming up with somebody asking, is anybody familiar with them? This one here is labelled up as a transistor because I can see base, emitter and collector. But on the other ones, and that does look like a similar kind of font, I think, it looks like it's an N-channel MOSFET, a 30 volt one. So if I have a look here, 30 volt N-channel, 30 volt N-channel MOSFET. See, I don't think I've got any N-channel MOSFETs like that. My MOSFETs are all big things. Do you know what I'm going to do? This should work without, this should work. It should at least turn on. I'm wondering if there's more problems. So let's not get too involved with this yet. If we pop that out, because I presume we've got a short, so I'm on continuity. Right, so we're shorting between there and there. Not there and there. So that's connecting the positives of the heat onto this here, which goes to that resistor, through that resistor, and I presume into this chip. Yeah, there on the chip. So this one here, see, I don't understand. If it's just connecting that, oh, sorry, that's the signal. I presume to make it work, it needs to connect this, because where does this go to? This is the massive one. Is this the ground? Here, through here. Is that ground? Yeah, that's the negative. So it needs to be connecting the ground through to, but then the ground, that's coming up on the reds. What? Does it make sense? So is it switched on the ground? Anyway, I think we need to take that off. In fact, what I can probably do is I can probably just cut that straight off because it's all over the place anyway. That is well and truly burnt. So I just want to make sure there's no path through it. I haven't cut the pads off there, I was actually careful. There's still loads of metal on the pads. I can put that back on later. Let's just make sure. Right, so you can see now there's no short. Should we see if it comes alive now? Because it should still come alive unless something else is gone. This video is sponsored by... Hold on, something's not right. That's better. PCBWay. Do you like purple circuit boards? They're usually more expensive, but not this October. PCBWay are offering purple circuit boards without any extra cost. Yippee! But that's not all they're offering. They're also offering discounts on flexible TPU. Vinny boy, what is flexible TPU? Very good question. Flexible TPU is a 3D printing material and it's known for its rubber-like elasticity, but yet it's tough and also durable. So it's like a hard plastic, but you've got the flexibility of rubber. And PCBWay have discounts. Check out their website and you will currently see they have 40% off. If any of this is of interest to you, you can check out the link in the description down below. Now, let's get back to the video. So plugging that in there. Plugging this in here, turn it on. Now let's see. There we go. So that was stopping it from working. So that's the massager side of it. If you hit that, I presume it goes the other way. Would this be intensity? Yep. But now heat's not going to work. Is it going to light up red? No. So it's not lighting up red. So with these, there's just lights in. They don't really produce much heat at all, even though it calls it deep, a deep tissue massage. There's very little heat. So why don't we... So does it just... I'm a bit confused why it needs to be a MOSFET over a transistor. Is it just because it needs more power than the transistor can provide? And then that's why it needs a MOSFET? I kind of need to... Let me just do a little bit of research to find out the difference between a MOSFET and a transistor. All right, of course, it's super confusing. All electronics are. A MOSFET is a specific type of transistor that is voltage controlled, whereas a traditional transistor is current controlled. Okay, so on a transistor, to turn it on, you need a small current flowing into the base terminal. Greater than 0 will turn the transistor on, but it requires a continuous base current to stay on. So we can guess which one is the base, because I presume it's the one from the chip, because that's doing the turning on. While on a MOSFET is voltage controlled. See, that's what I don't understand. I know what voltage and current is, but in this application here, or any application, when it says current controlled, so does it mean on the transistor you're going to have 5 volts on the base, but at 0 amps, but then when you actually get it turned on, it's still 5 volts, but it might go up to, for example, like 500 milliamps. That's what doesn't make sense. I kind of get the voltage one here on a MOSFET, because maybe it's going to read 0, and when the chip tells it to turn on, it might go up to 3 volts. Obviously, my electronics knowledge is massively lacking, as you all know. Anyway, it says here, a voltage applied to the gate terminal, which is going to be the same as the base, creates or modifies a conductive channel between. So what's happening is, when you turn on the base or the gate, it just allows the other 2 points to fully turn on with more voltage or more current. In a way, I suppose, could you call it similar to a relay? Because with a relay, you're using a small amount of voltage to control, for example, like mains voltage. People are going to laugh at me now for that comparison in the comment section. So it says here, it requires a specific gate to source voltage, threshold voltage to turn on. But maybe then it turns off. Because it says here, very efficient as they draw almost no current at the gate terminal once activated. Oh, I don't know if that's going to make any difference, is it? Because I'm not going to be measuring current anyway. I'll tell you what we're going to do. We're going to turn it on, and when I hit the heat button here, let's see if we have anything on that base one there. I think I'm going to get my bench power supply on here. It'd be easier for me to work. Right, 11.97 volts. Are you going to turn on? Yeah. Okay, I haven't got enough current. 1 second. Oh, it does. It draws 340 milliamps. Right, let's now go to the heat one. So let's see if we have anything here. So negative. Negative is going to be, hold on, this one round here. Let me just see which way it is. Is this negative here? So that's negative. Which looks like it's going up through here. Around to here. So we've got 5 volts there. So what happens when... How am I going to do this so you can see? Let's hit the heat button. Will that go to 0? Oh, it's gone the other way. Will that go to 0? So I'm going to hit the heat button now. Interesting, it goes to 0. Does that mean it's a PMP? I need to double check that. And now turn the heat off. Back to 5. We've learnt something there. Now I just want to double check that there definitely isn't anything going up to here. No. Okay. And I want to go between here, and I just want to use the negative here. So 100% is going to do the same there as well. So when we turn it on, it goes to 0. So let me just turn that off. And now we're going to turn it on. Yeah, so I need to find out if a transistor or a MOSFET goes to 0 on the gate. Is that PNP or you know, what is it? I think that might be a PNP transistor. So I still don't know if it's a transistor or a MOSFET, but I don't think it's that AOLA, because that definitely said N channel. And with an N channel MOSFET, it turns on when a positive voltage is applied to the gate relative to the source, while a P channel MOSFET turns on when a negative gate source voltage to turn on. So I think this is either a PNP or a P channel. I'm just going to double check what difference between a PNP and NPN transistor. Yeah, so again, NPN needs a positive signal to the base and a PNP needs a negative signal to the base. So the very fact that there's 5 there and it goes to 0, that says to me that it's PNP or a P channel MOSFET. I can't find anything online about what this transistor can be, or P channel MOSFET, but if we think about it, we know we've got 12 volts coming in, and if you have a look here, this is the positive, yeah, from where it comes in, and it goes round here straight up to the heat things. So these things here are heats. We have 4 wires, 2 negatives, 2 positives for either side. So there's going to be a heat thing here and a heat thing here. Now from memory, these heat things are minimal. I think they're just tiny little LEDs, some sort of infrared LED things. So the most it's going to be switching is 12 volts, because this can't turn on. If I was to bridge this here, they would turn on, because then we would, no, sorry. If I was to bridge this here, it would turn on, because we have it going from the positive here, going all the way up to here, through, let's call it the little infrared lights, back down here, and it's not doing anything. But then when this sees the negative, when this gets brought down from 5 volts to 0, this is going to switch here, turning this on, which goes around here, through here, back down to this one here, the negative, causing it to go on. So as far as I can see, the most we're going to have is 12 volts. And the most the power supply is, I think it said it was 12 volts, it was 2 amps. So the most we can have is 24 watts. And I'm pretty sure the infrared things are going to be nowhere near 24 watts, because remember, the motors have to work. So that also has to come out of the 24 watts. So whatever this thing is here, I don't think it needs, well, we know it's not a massive MOSFET, but I don't think it has to be that big. So I don't think I have to worry too much. I think I can probably put in any PNP and it will work. And if that doesn't work, maybe I need to look into a P channel MOSFET. But I think a normal PNP transistor will probably work, but I'm not actually sure. But that's why the comment section is good, because when I read the comment section, I'll fully know, and I can always swap this to do, you know, I can always swap it and put in a component that the audience recommends. Right, I've got a transistor kit here. One of these ones you get from eBay that come from China. So I need to find something in here. This is going to take a while. Right, I haven't gone through every single one, but I think this one might fit the bill. So this one here is a MOSFET. It's up as a MOSFET, so you can get MOSFETs like that, but it's a N-channel MOSFET, and I'm pretty sure I need a P channel, so I don't think that's suitable. So the very fact that it says A on here, maybe A does denote MOSFETs when it comes to these small packages. But to begin with, I think I might put this one in, because it says here, this is a S9012, 2T1 will be written on it. And it says that it will do, it's a PNP to begin with, and it says that collector base voltage is 40 volts. Well, that's going to exceed what this can do. Collector emitter voltage, which I think is going to be the important one, 25 volts. And it says that the maximum collector current is 0.5 amps, which is quite high compared to some of the others. And if the collector emitter is 25, that says to me it's going to be 12.5 watts that is capable of, which I don't think these heat things are going to be anywhere near. So I removed the old burnt component, the old legs off that, and it's kind of welded itself to the board, so one of the pads is quite damaged. And then we need to get the new PNP transistor in place and make sure it's making contact on all 3 legs. Then we can test it to see if it works. Right, bench power supply on. And let's just turn this on here. Oh, it's not working. Oh, hold on. Have I not got it plugged in? Yes, I have. Why are you not working? Let's try that again. On. It's not happy. Have I got a short on it again? So now we have a short between, no, 1 second, sorry, let me unplug the, yeah, no, I've got no power in. Now we've got a short between here and here. take that out. Let me see if I've got a short on the actual transistor itself. Yeah. Is that because it's damaged? Well, hold on 1 second. Let's just plug it in now and see if it's going to work. Yeah. Right, I suppose what we could do is unplug this here and see if we have some weird, you know, is this what caused it to go wrong in the first place? So they go up inside here somewhere. You don't want to come off? No. Right, how do you come off then? Oh, there are the lights underneath. Can you see the red lights here? Here they all are. Hiding under here. So I need to take this off completely. Oh, what? Oh, you just you just take it all off. Why? What on earth? Oh, because I was putting pressure at the side. Isn't that amazing? Look how easy it comes off and it wouldn't come off then. Right, you are. Now, I wonder how I can test these. Should we go onto diode? I wonder would diode light them up at all? So I'm getting, I will be just getting a short one because they're not LED, these are little lights. Should we see if one of them's giving me a different kind of reading? Are any of the legs touching? Shortened together? I think so. Well, how about if because we know it's going to be 12 volts, how about if I put 12 volts in here and see what happens to my bench power supply? Will it come on? If my bench power supply goes off, you know, it's going to indicate a short, isn't it? So I think we'll do that. I'm going to use this here. Take these out of here. So I'm going to use this. And let's go straight in. I'll go at a lower voltage just in case. But as far as I can see, it's switched at 12 volts. Let me go down. I'll go down to 5 just in case. Right, I'm at 4.8. Let's see if anything comes alive. No, not drawing anything. Ah, they've come alive. Now, why are they alive, but these are not? Oh, it's because I'm not on the right one. Oh, now we've gone into constant current massively. We've got a problem on this side here. Something's not right here. This is good. This is interesting to me.
Get alive, Venus.
So this is why the transistor blew up in the first place, I think. There's a fault on one of these. Ooh. Ooh, everybody. We've got that little game again. Are you ready? What do you spy? Take your time. Red lead, black lead. So this track is on the red, goes up to here, so you can see 1 light, 2 lights, 3 lights. Where's the 4th? Hold on. Oh, because there's 2 here. Yeah. So 1 light, 2 lights, 3 lights, 4 lights, black lead, 1, 2, 3, 4. But can you see something that doesn't look right? Give yourselves a pat on the back if you spotted that there. We have got a bridge. So let's go to, let's plug my leads back in. We'll go to continuity. And look, got a bridge there, even though I'm unplugged here. But the lights, would the lights give a bridge though? I'm just going to go across the other 2. I wonder what, because the lights are also going to give a bridge, but they're going to give a different reading. 3 ohms on my meter. Yeah, look at this. So the lights themselves are obviously going to be a short. If I go across here, you'll see, because that's connecting the whole thing. So you can see 3 ohms, but when we go here, my leads are actually 0.5, so less than half an ohm. And if I go here, can you see? That's not the lights we're reading. That's the shorts. Yeah? Less than an ohm. 3 ohms. Less than an ohm. So that there is the problem. And that's why it shut down, because obviously one of the chips must have noticed that there was a short on the output and for safety shut it down. So when this was being made, this is faulty from manufacturer, and I can't even see how that got through quality control. Well, maybe the other lights lit up for a minute. Maybe it didn't blow straight away. But still, that hasn't happened in transit. That is rock solid together. There, because that was bent over. Right, let's cut that off to stop that from happening again. There we go. So that's got no chance now of bending over. Make sure all the others. I love detective work like that. That to me is everything. You know, I think I just pulled that right the way through. I don't even think that one's soldered properly. There we go. Now let's measure current now and see what it's doing. So first of all, I am going to get my bench power supply again, and let's see if we can get these lighting up. If I can put that transistor in and then get this working, it'll be, and I often say, but it'll be one of my favourite videos. Now let's see. So if we go between here and here, we have those lighting up. And now if we go here and here, no longer have we got constant current, we've got them lighting up. Isn't that good? There and there. Fantastic. Look at that, you can see the little burn mark just there on the casing. Right, let's pop this one back in. Like this, hopefully I can get it on. I think I can. There we have it. It's not bad. Let's give that a clean up. Right, and now let's see if it works, and if it does, I'll put a little bit of nail varnish on that. Now, is that PMP going to work? I'm going to say yes. Right, 12 volts is in here. You're kidding me. Seriously? What? Oh man. It was my favourite repair, and now it's quickly going downhill. Right, what's where's the short? What's happening now? So clearly it's not happy with that, because we have a short between here and here. Do we have it on a good one? Because maybe when I put that in to begin with, it blew straight away when this drew too much current. Let's see this. Do we have a short between the same pins? No, we don't. Ah, my little transistors failed because we didn't get the root cause. That also worries me, because why didn't it go up in flames like the first one did? Which makes me think that maybe this isn't going to be beefy enough. So I solder in a brand new PMP transistor. Let's turn it on now and see if it's working. Here we go. On. Good. Now, is it going to go up in flames when we turn the heat on? It's smoking. It's smoking. It's smoking. Wow, it's sizzling and smoking. Oh, whoa, 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 yeah. Oh, Vince. And that's not even... Oh, now it's come on. Now it's come on. Better cut power to this before it breaks something. Yeah. Yes, that's completely shorted now. That there to there. Oh, I don't know what to do. Is it an NPN then? Right, out of desperation, I'm going to put in that A chip. That was down here, the A MOSFET one. And that's an N channel one. Because my P channels don't appear to be working. This one here. So the one I'm going to attempt now is an N channel MOSFET, and it's marked up as A03400 or A09T, and apparently it's a 5.7 amp 30 volt N channel MOSFET, a SOT23 package. So we know that this whole massager is 12 volts at 2 amps. So if this is 30 volts at 5.7 amps, you can see there's more than enough there to handle the heat part of it, because the heat and the motor can't exceed 12 volts at 2 amps, because that's what the power supply is. So if this works, it should be able to handle it fine, in my opinion, but I haven't got a clue. Okay, I managed to get that in without the wire because the solder's gone so blobby that I just moved the transistor up a little bit. Right, let's check for shorts. No, no, no. Okay, now let's see what happens when we put the N channel one in. And this is a MOSFET apparently. Good, the lights are not on right now. Here we go, turn on. Oh, that's fine, it's just the other way round. So when I do this, so hold on, when you turn it on, do the lights come on automatically? Yes, maybe that's normal. In fact, we can see how much the lights draw, because my bench power supply goes from, when they're off, it's 12 volts, 0.32 amps, and on 0.98 amps. So that is, drum roll please, 660 milliamps, so 0.66 of an amp more when you have the heat option. So you can see that this little MOSFET should be able to handle that, no problem. Okay, let me measure the voltage. Should I tempt fate to see how hot that is? Oh, it's not. Oh, it's not. Maybe by default, when you turn this on, these should be off, and then you put them on. But maybe not. Maybe that's to turn them off. Maybe when you turn them on, they should come on. Let's see what we have across here now. So we have 5 volts when the lights are on. Now let's see if we turn it off. Do we then have nothing? So maybe I was measuring it wrong. I had that as going on. So maybe my logic was correct, but I had it as going on when you press this and off normally. Because I thought when you turn it on, you would have to turn this here to put it on. But now I think you just have to turn it off. So if it was the way I thought it was, then it would have been, I would have been, yeah, if it was this way, if I'd known, then it would be 0 volts. So I think it is N channel. Then when you press this, it goes up to 5 volts. Okay, I think that's quite a genuine, mistake, and I don't think I would have been the only one to fall for that. Because you see, I don't know the product. If I'd known the product, you would have known that these come on automatically. I think that's going to be suitable. It's not getting warm. I can prove that with my thermal cam. Now if you have a look, can you see that we have no Just wait for it to catch up with itself. There you go. You can see down here that there's no heat on that little MOSFET transistor thing. Right, I'm going to put this back together. Please tell me in the comments section if what I've done is incorrect and if you know what that should be, because it's only going to cost pennies to buy them. I'll probably get 10 of them for like £2. So yeah, please let me know what that should be. Can we say this is fixed? I think I'm going to call it fixed. We have, I can feel heat being generated from here, and there's no, I don't know why I feel so nervous touching this, but there's no heat from there. Okay, I am going to put this back together. So it's just time to put it back together, so a perfect opportunity to shout out that my mate Vince Massive. The members this month are Keemon Services, Kip Hakes over on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJ VG, Pigsy, Anthony Dean, Russ Melanson, Ricard Berglands, Shamsa Al-Sawadi, Stuart Park, Stephen from the Broken Past, over on YouTube, Lee Benz and AJ Computer Services UK. As always, a massive thanks to each and every one of you. I wouldn't be happy selling that, but I would be happy to use it myself, maybe give it to my dad, or maybe friends and family who knew that there's a risk in using it. So in other words, don't leave it plugged in when it's not in use. I'm trying to look good on camera, but I can't. Ooh. It is. When you rest your arms in here, you see the weight of your arms is pulling it deep into you. And when it says a deep tissue massage, you really are getting that. And it could just be the heat from my body, but I am feeling the heat from this. It's a little bit more rough than, it's not very gentle, but I suppose you can have it less gentle by lifting your arms up, but you know, naturally you're going to be like that. It is, it's really working in there. But I've had one of these before and it never got used in the house, and that's the reason I gave it away. But you know, it might work. I've also got a foot massager that everybody was raving about for about a week, and now it's just left there. That's the problem with gadgets like this. In reality, they don't get used very often. But anyway, I thought it was an interesting fix. Yes, I kind of ruined it. Obviously, it would have been great if I picked the right transistor to begin with, but what would you have done in that situation? How would you have known that it wasn't PNP when you don't know the device? Did I make a schoolboy error that I should have known? If you could explain it the way you would explain it to maybe an 8-year-old, then maybe I'll know for next time. Anyway, I'm going to enjoy this for the next 5 minutes or so. If you enjoyed it, give it a thumbs up. Thanks for watching, everyone.
I feel like I've been here before, familiar with the view. This ain't nothing new, and every time that you walk through the